So let's go to the next lecture then. Okay, I'm starting up the recording again. Yeah, here. Okay, so let's talk about estimating defects. Okay, so when monitoring a progress of a project, it's important to have ways of quantifying how are we doing, how much progress are we making. And there are certain classic ways of trying to measure this. Give me one way of measuring sort of how far have we come thus far. What's a way of sort of judging how much work have we done? Give me a classic way of sort of saying how much work have we done thus far? Lines of code, good. And there's all sorts of variations of it. You know, lines ignoring comments and ignoring white space and various things like that. But really it comes down to sort of how much code have you written. And hopefully code has been written, it compiles, it's linked in with other code, etc. So that's good. That's an output. And as such, it's more valuable than some things people look to ask how far have we come. Other people, when they ask how far have we come, how much have we done, they'll use things like how much money has been spent, or how many hours have we been working on this. And those are less interesting, folks, because those are inputs. Those don't really tell you how far along you are, tell you how much you put into it, but not what you've gotten out of it. So lines of code is actually a good one. And it's a tried and true one. And, there may be others, function points implemented, which can be estimated early on. So it's kind of a nice one because you can estimate it early in a project. Number of classes created, number of test cases created. That's good. But one of the most fundamental things that shapes whether a project succeeds or fails, ladies and gentlemen, is harder to quantify than lines of code. And it has to do with the quality of the code base. It has to do with what sort of quality is this code base. Because if you've got a code base that's chock-a-block full of defects, you've got a lot of work to do. Maybe the same number of lines of code, but it's full of all sorts of problems. Some of them perhaps undiagnosed. And you've got a lot of work to do. Other code bases may be very clear, transparent, easy to understand, flexible, modular, and with the same number of lines of code, well tested, and you're a lot further along. So naturally there's an interest in trying to quantify things related to quality as well. And there's a whole set of metrics you can run in your code bases. And I like to encourage people to do this. So there's a program you can run. People will often run it associated with things like builds. You might run programs like CheckStyle, and that will actually go through and systematically check your code to see if it's conforming with the style conventions of your project. You can go out and find about it, look it up, and you'll find that you can define your style conventions for your project, and it'll check adherence to that. And that's good. Other programs will spot potential errors. For example, the Sealint project that some of my stuff has contributed to years back. It'll spot potential problems with your project's code. There's things to estimate the number of lines of code per function or per method, for example. And those can spot really long methods, or the depth of nesting of your methods. How deep are the if statements or whiles and loops and other constructs, which can lead to cognitive overhead. So there's ways of estimating those things from code bases, and there's a lot of tools which do that. And I'd encourage you to think about using them on your code base for ID5. But what I'm going to talk about today is even less directly tangible than those things. It's about how do we estimate defects, and particularly, ladies and gentlemen, gets at the issue of how do we estimate undiagnosed defects? After all, we found a certain number of defects, hopefully, when you're testing. You have issue-based, whether it's JIRA or Track or what have you, that you're using to track defects that have been reported, right? Someone ran the app on such and such a tablet and it crashed immediately. Someone else ran it and the text was all screwed up on their smartphone, whatever. And you record those defects in your defect database, right? Yeah? So those are a certain number of defects. But what should be giving you worries, concerns, particularly those like the project managers, is how many defects are there out there that we don't know about yet? Okay, maybe we have a small number of defects. Is that bad or good? Give me a reason a small number of defects that you have in your defect database could be good. Small number of undiagnosed defects. How could that be a good thing?
You've actually caught the majority of good testing. You really just don't have that many problems.
Great. High quality coding, perhaps. Really good testing. On very few cases. You're golden. You're in great shape. Coming in for a soft landing for ID5. Why could a small number of defects in the defect database be a bad thing?
Could be that your detection methodology is horrible.
Yeah, it could be you're very ineffective at doing testing. You haven't been really serious about it. You haven't really created test cases to put it through its paces. You're covering a very small fraction of the code. And you've only detected a very small number of bugs out there, but there's a much larger set that are still out there. Latent bugs, just waiting to be, to afflict your system when it's demoed to the user or to the prof or what have you. So in today's lecture, in the remaining minutes, we're going to be looking at ways of trying to estimate our defects. And there's three basic methods discussed here. And I'm going to be giving just a nod to the first method. I'm going to be spending a little bit more time in the defect seeding, and we're going to talk more about the defect pooling. Because, ladies and gentlemen, I expect you, in the coming 10 days, to undertake defect pooling approach, okay? I expect you to report to me some estimate of the total number of defects in your system through defect pooling type exercise, okay? And one of the best ways to do it is to have 2 bug parties, and each runs for 2-3 hours. Do it over in Sphinx, maybe different areas of Sphinx, independently. And out of that, you can get a single estimate of how many bugs there are out there in the program, including undiagnosed bugs. Easy peasy, satisfies the requirement. I'll be a happy camper. Okay? So this lecture is geared towards you folks at this point in your projects. So each of these approaches is imperfect. But it's a lot better than just having no clue at all how many defects are out there. There's complications, there's assumptions, there's some duplication of effort involved, but I would argue it's a lot better than just throwing up your hands and saying we don't know how many undiagnosed defects are. So let's talk about these 3 approaches. The first one, as I noted, I'm just going to refer to briefly, and that's the use of historic data. It's going to be very effective for companies like IBM or Microsoft or Google, which are long, projects which have been around for years, and established teams, lots of data accumulated over that time, and they have some historic data on which to judge. And so, if you have a similar team for previous versions of Microsoft Excel, and you have some defect density that was estimated for those after a lot of testing, and you're early in the testing for this next version of Excel, you might be saying, well, we're trying to estimate the total number of defects. We found some number of defects so far with this version. And as far as density, in terms of defects per lines of code, maybe that's a defect of, 1%, a defect density of 1%, 1 defect per 100 lines of code, for example. But historically, maybe we know we have defects of 10 defects per 100 lines of code. And so, we're just getting into it. We have a defect density of 1%, defect density of 10%. We've got a long way to go. We found, 60 defects thus far. And we anticipate, therefore, we'll find 0.1 divided by 0.01. That ratio is 10 times 60 or 600 defects out there. Okay, so here we have some defect density we've found based on previous versions or what have you that we think is kind of typical of our team. And then we have some number we found thus far in this iteration, and we multiply that times the actual number of defects we found. The primary problem with this is past results, as they say in financial world, are not necessarily indicative of future performance. What could change, ladies and gentlemen? Why could this be off? What could change? Why might it be that this isn't too reliable?
Maybe you start using pure programming, pair programming, and then you plan on a lot less defects.
Good. Your processes have changed. Maybe you put in place aggressive pair programming, you put in place aggressive peer review or better testing infrastructure. Maybe you're doing work this release using largely the component of your browser technology that has to do with scripting, and past versions have dealt more with fundamental issues concerning CSS or XML. And so you can't really often directly compare bugs here with bugs in previous versions, because the defect density might be very different. In one case, we may be dealing with defects in one language versus defects in another language. Also, there's turnover in your team, right? The people who are in your team now may not be the same people who were there a year ago or 2 years ago. Maybe there's a lot of newcomers now. How are they going to change the situation? This really doesn't let us directly address that, right? We have a lot of new people on the team. Maybe our new defect density will eventually be twice what it was in the old version, because we have people who are just getting to know the code base. So we can't really rely on that typically. Even in a large company, it can be kind of dicey with a lot of experience. So the second approach is doable. It is something you folks could undertake. It may seem a little bit risque, but it's effective and takes some planning. I would argue it's not quite as desirable. It's not as desirable as the final approach for reasons I hope to talk about today. Okay, so here's the question motivating this and this approach. So suppose that you wanted to estimate the total number of fish in a lake. There's some fish in a lake. Maybe it's a big slough. Maybe it's a bigger lake, Lake Diefenbaker, or what have you. Suppose you want to estimate the total number of fish there. And you have 100 fish tags that you can put onto a fish's fins, and it will identify that fish that you have caught that before, a certain number with a certain number associated with it. How would you proceed with these fish tags? How could you estimate the total number of fish in this lake?
You could tag 100 and release them, and then catch more and see what proportion of time.
That's exactly it. Beautiful. Beautiful. So Matthew got it exactly. So here, suppose you tag and release 50 fish. So you drag a net and you take these fish and you tag them, and then you release them. And then you catch 100 more fish, maybe a couple days later, right? You release the fish maybe all throughout the lake, and then a few days later you go through and you trawl and you get 100 more fish. And you find that 5 of these caught fish were tagged. How many fish would you guess are in the lake or in the pond? So originally we caught 50. Now we've refound 5 of these at this phase out of 100. How many fish would you guess there to be in the lake total?
Around 1,000.
Okay, around 1,000. Great, Wei Zhong. So where do you get that number? That's exactly right. So where do you get the number?
5 divided by
100 equal to 50 divided by something, and then evaluate something.
Okay, so I'd have to talk to you to understand that, but let me put it this way. So these 5 are 10% of these 50, right? This is 1/10 of the 50 that we found. So we went and we caught 100 fish, and we found that among those fish, we got 1/10 of the original number we found, right? So we might say, well, if these 100 fish included 10% of those we tagged, and if those we tagged are kind of representative of fish in general, maybe these 100 represent 10% of the whole lake, right? The whole lake's population. Assuming we haven't specifically gotten, there's something about our trawling which is giving us the same type of fish. If we're getting 10% in these 5 fish, if that's 10% of the tagged fish, maybe these 100 are 10% of all fish, right? In which case, if 100 is 10% of 1,000, okay? So the idea is that, we kind of estimate, we know from finding these 5 that we've caught 10% of our tagged ones. So we'll say, well, it's probably pretty representative for all the fish we catch. It's 10% of all, these 100 are 10% of all fish. Does that make sense? Now remember here, we're only catching, in the process of this, 50 plus 100 fish, 150 fish out of the 1,000. Well, we can estimate the number of fish out there. Even though we haven't gone and caught them, we can estimate there's probably about 1,000 out there. It's imperfect, but it's probably better than just guessing. Like, what the hell? 10,000 fish. I mean, you could create a wild guess, but this is going to be off. It's no doubt going to be off somewhat. Maybe it's even off by a factor of 2. It's unlikely to be off by a factor of, 10 or 100, right? After all, we know for sure there's at least 145 fish in that lake, right? There's these 100 plus the 45 tagged ones we didn't catch this time, right? So we know something. Okay, are there assumptions here? Yes. The catches of fish are independent. That, we're not capturing the same sort of fish. We're not just trawling the top meter of water and there's tons of fish below that. We're not sampling at all. We're kind of assuming that we're doing a pretty good sampling of this, right? So here we've kind of got some defects and we've got some tag defects. And the proposal here, ladies and gentlemen, and this is done in real projects, is you actually seed defects. You introduce into your project defects. Temporarily, of course. And you record exactly where they went, right? You record precisely where those defects are placed, and you put them in there. Now, that sounds perverse. Why in a real-world project, under testing where people are working hard and so, why would you seed defects? What possible good could come from that? Anyone?
You can evaluate your testing.
Yeah, you can evaluate your testing. You're in a bad zone. If you're introducing, 50 defects into this code base, and you're not detecting any of them within the first 2 weeks of testing, it's not a good sign. It's not a good sign that your testing is being very thorough. You're probably missing lots of other similar sorts of defects, right? You're putting in lots of off by 1 errors. You're putting in lots of errors, in terms of a updating of a value to an incorrect number, in terms of a miscalculation at one point, and you're not detecting it. Well, that's not very encouraging about your testing, but it tells you something about your testing that at least it's not, it's not catching, probably not catching a lot of stuff. So defect seeding is pretty easy to do. You have to be absolutely sure where you're putting it, and so you can go take it out later. You record precisely what you put in, and you try to put in bugs that are kind of representative of things you found in the past. So they're not wildly easier to find or something than most bugs. Okay, so So the basic reasoning is very similar to the fish tags, right? These are our tagged fish, the seeded bugs, and we see what fraction of all the total seeded defects we found within 2 weeks, and we see how many total bugs we found within those 2 weeks, and we multiply that ratio just like we do with the ratio of tagged fish. We multiply this ratio of the total number of seeded defects, which we know, just like we knew the number of total seeded tagged fish, divided by the seeded defects that are actually found times the number of defects found, right? So maybe you found, of all the defects you introduced, 50 defects you introduced, you found 5 of them within that 2-week period among the 100 bugs that you found in that 2-week period, right? In which case you probably got about 1,000 bugs. So same exact numbers, same exact reasoning as for the fish. Seeded defects, again, should be fairly representative of things. They should be broad areas of functionality, many levels of severity, and you seed prior to the beginning of the big set of tests, okay? Now, there's some caveats here. You want to keep them pretty simple, and there's questions about how representative of that will be. You certainly want to eliminate them before shipping. You don't want people making added mistakes based on these defects, for example, fixing them in wrong ways or what have you, and have that screw things over. They could cause resentment. People are going to be spending hours debugging this thing, and it's just, oh man, you stuck that in, buddy. So I stayed up till midnight last night trying to find this bug that you stuck in. Are you trying to save this project? Or are you trying to kill it? That can cause resentment sometimes. Attempted fixes can cause new problems, and sometimes people don't fix them properly. You go to remove them, and it's not so clear. That code is moved somewhere else, and you end up making a mistake. So you have to be careful about that. The method I recommend to you folks, so you can do seeded defects. That's great if you want to. It'll be the first time in a long time that anyone's done that in this class. The method I recommend is actually much more staid and much more, I think, much less problematic than that. And that's defect pooling. Okay. So the idea here, folks, is that you have 2 teams working ideally in parallel at the same time without communication. Say a bug party, 3 hours, different areas of space, one on one side of the big lab, one over in the area closer to the entrance or what have you, and they're working at the same time trying to find defects in your code base. 3 hours. One team finds, well, this would be pretty aggressive, 350 defects, the other finds 400. That would be a good night. Okay, maybe they're working from, 4 till midnight or something. You're just cranking in defects. And you find that there's an overlap of 150 defects between them. And that's the key thing. Ladies and gentlemen, in terms of the total number of defects out there, will the total number of defects tend to be, total number of defects you think that are going to be out there, will it tend to be larger or smaller as the number of common defects grows? If we have more defects found in common between these teams, would it suggest that there's a larger number of defects out there or a smaller number? Smaller number. The bigger the overlap is, the more they're finding the same defects between the 2 teams. It's probably indicative that there's a smaller number of defects out there, right? On the other hand, if these 2 teams are working their butts off in these bug parties finding defects, they're hitting the system and they're really working with it and finding defects. One finds 400, one finds 350, and they find they have a single defect in common. What do you think the implications are for the number of defects out there? It's a lot of them, right? A lot of them. It could be a lot more found. A lot more where they're coming from. So the idea here, folks, is to establish 2 independent pools of defects These teams should be working independently. They shouldn't be sharing information about where to look in the program, what screens they're pounding on. Be operating independently, and test really the full scope of the software, right? Should be different people. You can do it with teams operating at different times, but then they may remember from the earlier time which areas were soft, so it's no longer independent. The basic estimation formula here, and I expect you folks to know this, just like for defect seeding, is the total number of defects is equal to the number of defects in pool A times defects in pool B divided by the number of common defects, namely the number of defects that are in that overlapping area, both A and B. Okay. So there's also a fish analogy for this. So pool A, fish caught for tagging. Pool B, this is the 50 fish originally caught for tagging. Pool B, the 100 fish caught later. The defects in A and B are the fish caught in the second round that are tagged. Of those 100, what number were tagged? 5, right? Since we caught a number of, we had this intersection, 5 divided by 50 of the tagged fish were caught within pool B, within those 100. We estimate the fraction of all fish that we caught in pool B. So the fraction of all fish we caught. So if we found 5 out of the 50 within those 100, we estimate, well, if it's 5 out of the 50 tagged fish, these 100 are probably 10% of the whole lake. And so we have A here, say 50, the number of tagged fish times B, 100, divided by the number in both, 5, right? And so it's 50 divided by 5, 10 times 100, or 1,000. Does that make sense? Yeah? So ladies and gentlemen, I would submit to you, I would strongly suggest that you use defect pooling. I think it's easy to do. Past teams have reported that bug parties, having a time where the teams come together, work side by side, and you just pound your software, try to find bugs, and record those bugs. It's a great exercise. Teams find it fun. They sometimes give out prizes for the most creative testing strategy, or the most bugs found, most interesting bug found, most serious bug found. You could do that. Bring along some pizza and have a go at it. Do it at 2 teams at the same time. You can cap the night with doing this computation. How many defects are out there? Straightforward, right? Straightforward, and it gives you some sense about where we're at. Okay, we found a bunch of defects. How many more are there? It's great news if you found all the same defects. Maybe you caught all defects. In fact, it's sobering if you've caught very few, but just knowing that you've actually taken the time to estimate that will be great from my perspective. Okay? Okay, so that's all for my lecture on estimating defects in pooling. I think you have time to do that now with your teams, and hopefully we'll get to see this in the final report. Okay? Any questions about that? Okay. Then I think we'll wrap up a minute early today, and I wish you the best of luck. I know this is the second to last weekend for the projects. I know they're working hard. I'm going to try to get you some updated comments on your projects, and I wish you the best of luck in this course and elsewhere in the coming week.